start with the fourth chapter, two-dimensional kinematics. Motion with constant velocity, motion with constant acceleration. We'll consider that the motion of Now from this video we'll start with the fourth chapter, two-dimensional kinematics. And the motive of this chapter is to understand that horizontal and vertical motions are independent. Okay, so let's start with the first topic of this chapter, the motion in two dimension. And under this topic we'll study the equations of motion to describe objects moving in two dimension. First we'll consider motion with constant velocity, and then we'll consider motion with constant acceleration. Now here you see this figure, and this is a turtle that starts from origin and move with a constant speed of 0.26 meter per second in a direction 25 degrees above the x-axis. Now this is a case of two-dimensional motion. Why? Because the turtle is moving in x and y direction respectively. So it is moving in two dimensions and with a constant velocity. So this is a case of two-dimensional motion with constant velocity. Now think, how far has the turtle moved in x and y direction after 5 seconds? So suppose that after 5 seconds the turtle reaches here, right? Now this distance is given by the speed into time. So this we can write v0 multiplied with t. So this distance will be v0, that is the speed we have, 0.26 meter per second. So 0.26 meter per second multiplied with, now time we are asked after 5 seconds. So time we have to take to be 5 seconds. So that will be equals to 1.3 meter. Now we have to calculate that how much the turtle has traveled in x and y direction respectively. So you can see this triangle, let it be OAB. Now AB is the distance that the turtle has traveled in the y direction, and OB is the distance that the turtle has traveled in the x direction. So this distance, this will be d cosine theta, right? And this will be d sine theta. From our trigonometric formulas we can write this thing. Now it's pretty simple. We can find that how much distance it has traveled in the y direction. So y, this would be d, we have calculated to be 1.3, sine theta we have 25 degrees. So that will be 1.2 meter, and similarly x will be 1.3, but this time cosine theta, cosine 25 degrees. So that will be 0.55 meter. Now, an alternative approach to solve this problem is to treat the x and y motion separately. So let's discuss this alternative approach now. Now we'll consider the motion of turtle in x and y direction separately. So this is the direction of the velocity for the turtle, v0. Now its x component is represented by this arrow. This is v0 x we can write, and this will be its y component, v0 y. Now we can find the speed in x and y direction separately. So v0 x, this will be v0 cosine theta, which is 25 degrees, and v0 we have 0.26 meter per second times cosine 25 degrees. So that will be equals to 0.24 meter per second. Similarly, we can find its speed in the y direction. So this would be v0 sine 25 degrees, and after plugging the values we'll get this value to be 0.11 meter per second. So from here we can say that in x direction it is traveling with this speed, and in y direction the turtle is traveling with this speed. Now what would be its distance traveled in the x direction? This is pretty simple. X is speed multiplied with time. Now speed we have to take to be v naught x, and time t. V naught x we have 0.24 meter per second, and time t we have to take it to be 5 seconds. So that comes out to be as 1.2 meter. Similarly, we can find the distance traveled in the y direction. So speed in the y direction we have this much, 0.11 meter per second, multiplied with time is 5. So that is equals to, this is 5 seconds, so 0.55 meter. So we obtain the same result that we obtained earlier, and this time we consider the motion separately in x and y direction. Now let's generalize the results. So in general, an object might start at a position x is equals to x naught and y is equals to y naught, and time at t equals to 0. Now in this case, the equations of motion in x and y direction will be, in x direction it will be x naught plus v naught x multiplied with t. This is equation 1. And second equation, in y direction it will be y is equals to y naught plus v naught y times t. This is the second equation. Now if you compare these equations with the equation that we derived in the second chapter, which was position as a function of time in one dimension, it was x is equals to x naught plus v naught t plus 1 over t square. This is the equation that we derived in the second chapter. Now in our case the acceleration was 0, acceleration for the turtle it was 0. So if a is 0, then we obtain that x is equals to x naught plus v naught t. Now if you replace this v naught as v naught x, we obtain the equation x is equals to x naught plus v naught x times t, which is the same equation. And if you replace this x with y, we obtained y is equals to y naught plus v naught y times t, which is the second equation. Now next I'll be taking one example based on these equations. Now in this example we are given that an eagle perched on a tree which is 19.5 meter above the water. So this is 19.5 meter above water, and spots a fish swimming near the surface. Now the eagle pushes off from the branch and descends towards the water, and its speed we are given to be 3.10 meter per second, and this angle is 20 degree below the horizontal. Now there are two parts in this question that we need to solve. First part, how much time does it take for the eagle to reach the water? So how much time it took to reach to the water? And second, how far the eagle have traveled in the horizontal direction when it reaches to water? So this x, the horizontal distance, this two things we have to calculate, right? So to solve this problem, we'll consider that the motion of this eagle in two dimensions. So this was the actual velocity v naught, which is 3.10 meter per second, right? And this angle below the horizontal, this is 20 degree. Now it will have two components in x and y direction. Now we have taken this as our origin. This is this is origin, this is the positive x and this is the positive y. So this will be its component in the x direction, and this will be the component of velocity in the negative y direction. So this is v naught x and this is v naught y. Now what would be its speed in the x direction? This would be v naught cosine theta, and this value will be minus v naught sine theta. And why this is minus? Because this is along the negative y. So we have considered motion of eagle in two dimension, in x and y. Now we'll be solving the a part. Now we know this was the initial position for the eagle and this is its final position. Now at the initial position, its x coordinate is 0 and y coordinate is 19.5, and this is the final position. X coordinate we don't know, let it be x, and y coordinate becomes 0. So I'll be using this equation to calculate time. Y is equals to y naught plus v naught yt. Now y naught is the initial position, which is 19.5 meter, and this y is the final position, which is 0 here. So we can put it here to find the time. Y is 0, y naught is 19.5 plus v naught y, we have this value minus v naught sine theta multiplied with t. Now from here we can write that this t will be equals to minus 19.5 divided by minus v naught sine theta, and this is in meter. Now we can put the values. So time, this will be minus 19.5 meter. V naught we are given to be 3.10 meter per second multiplied with sine theta. Now theta is 20 degrees, right? So this is 20 degrees. Now you can use a calculator to solve this, and we'll get this value to be 18.4 seconds. So this is the time taken by the eagle to reach to the water surface. Now next, in the B part, we have to find its horizontal displacement or horizontal distance traveled. So this will be x is equals to x naught plus v naught x times t. X naught is its initial position, the x coordinate, which is 0. So 0 plus v naught x. V naught x, we have v naught cosine theta. So v naught cosine theta and multiplied with time. So we can put the values now. X is equals to v naught, we have 3.10 meter per second multiplied with cosine theta. So cosine theta, we have 20 degrees multiplied with time is 18.4 seconds. So on solving this, we'll get this value to be 53.5 meter. So this distance is 53.5 meter. Now I'll be giving one practice question to you. You have to find the location of the eagle 2 seconds after it takes flight. So after 2 seconds you have to find its location. So this is all with this video, and in the next video we'll discuss the motion with constant acceleration.